Hello friends, in this video here you see this is part 4 of Statistical Mechanics paper C14 2022 6th semester Dibrugarh University. In this video we are going to solve from question number 4. Okay, we're going to complete the paper in this video. Okay, we have already solved up to question number 3. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. So now let's start. Here you see question number 4a, what is photon gas and what is the difference between the photon gas and ideal gas? Here is the answer. Let me give you the answer directly. This is the answer to question number 4a. This is the first page and this is the second page. Okay, so these are the difference between the photon gas and ideal gas. Okay, take the screenshot. So now let's move on to next question. Next question is, what is the Bose-Einstein statistics and derive this relation? Okay, so now let me give you the answer. So here is the answer to 4b, question number 4b. What is Einstein statistics? Take the screenshot and let me write the answer of the second part of this question, that is we need to derive this expression in the second part of this question 4b. Let me derive it. I hope the thermodynamical probability in case of Maxwell-Boltzmann statistics or Bose-Einstein statistics and Fermi-Dirac statistics. So in case of Fermi-Dirac statistics, it was W is equal to this pi, which represents multiplication gi divided by ni gi minus ni factorial. That is what we have got. I hope you know this. And in case of Bose-Einstein Bose-Einstein statistics, it is given by W is equal to this multiplication of ni plus gi minus 1 factorial and ni factorial into gi minus 1 factorial. Similarly, in case of Maxwell-Boltzmann statistics, W is equal to this thermodynamical probability, this multiplication of gi to the power ni divided by ni factorial. So it will be better if you remember these three things. What are the thermodynamical probability in case of Bose-Einstein statistics, Fermi-Dirac statistics, and in case of Maxwell-Boltzmann statistics. So because in this case, now for the time being we are not going to deal with the permutations, combinations and all mathematical tools. Okay, so simply I'm going to give you the answer. So let me consider a system of n independent indistinguishable particles. Okay, let there be n1 n2 dot 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 ni and nk particles having mean energy values ei. So in the question, in the expression that you can see that in this expression here you can see that instead of using E for energy, here it is given epsilon. So that's why for energy I'm going to use epsilon instead. Actually in some books, different books use different symbols. Sometimes for energy you will get this symbol and sometimes you will get this capital E also. So we're going to use according to our question. Let me replace it by epsilon as mentioned in the question, right? So let me write here epsilon instead of E. Okay. So here total number of particles is n. Okay, and these particles are distributed in ni indistinguishable particles are distributed among Gi cells in ith compartment. Okay, and then as I have already told you that in case of Bose-Einstein statistics, that thermodynamical function is thermodynamical probability is given by this expression, right? And this is for only ith compartment. For all the compartment we need to take the multiplication of all these probabilities. Okay, and this you see this value g is very large, g and n are very large, so we can neglect this -1, okay, in this equation 1. So then equation 1 implies this, right? Now let us take the natural log on both sides of this equation. So if you take log on this expression, then you will get this expression, because you see log of m divided by n is log m minus n, okay, log m minus log n. So if you apply this one here, then you will get this minus log or ln means natural log, ni factorial gi factorial, right? Now again you have got another property that log m into n is equal to log m plus log n. So that's why this ln ni into gi will become ln ni factorial plus ln gi factorial. Because of this minus, this plus becomes minus, right? Hope you have understood this. Now you see that's how we have got this expression using these properties of log. Okay, so now let me clean this. Now you see, so what we have done after this, just okay, now you see ni gi are very large numbers. We can use this approximation, that Stirling approximation, that ln ni factorial can be written as n into ln of n minus n. If we use that here and here, what we're gonna have, this is gonna give you ni plus gi ln of ni plus gi. Similarly this one will give you sorry, one more thing, minus ni plus gi should be there, ni plus gi. Similarly we can apply this one here also and here also, right? Here we're gonna get n ln n minus n. Here we're gonna get gi, then ln gi minus gi. Okay, so because of this minus will be plus, and because of this minus will be plus, okay, and so on. So if we use this approximation here, then this equation becomes of this form. Just let me go to the new slide. Let me clean this. Okay, just wait. Let me go to the next slide. Here, after using the approximation, we have got this state. Okay, now if we simplify this, after simplifying this terms within bracket, few terms will be cancelled out. Okay, if you open these brackets, sorry, not this one. Okay, you see, sorry, not this one. If you open this bracket, okay, these two will be cancelled with right, just give me a second, not this one. Let me check which terms will be cancelled. Okay, right, just wait. Yes, these two terms will be cancelled out by this and this, because you see here we have got plus ni plus gi, that is plus ni plus gi, which will cancel minus ni plus gi, right? Hope you have understood this. And after cancelling this two, we have got this. This is equation number 3. Now for the maximum state, we need to differentiate this, and that should be equal to 0. Okay, derivative of this should be equal to 0. Just remember the condition. Okay, now let me now differentiate this right hand side. Okay, now let me differentiate this right hand side. Okay, then what you will get, derivative of, you know, ddx of log x is 1 by x. So d of log x, it can be written as 1 by x dx. We can write that way, right? So if we apply that here, okay, then what we're gonna have, you see, in this case, here you see first we're going to use this as a product rule. This is first function, this is second function. First function derivative of second function plus second function derivative of first function, or you can write derivative of first function into second function plus derivative of second function plus into first function. So if we apply that, here we're gonna have this. So first derivative of first function, derivative of this one, here del gi will be equal to 0 because gi is not it is not variable. Okay, yeah, so that's why we got only del ni. Then second function is this, so product of into second function. Then first function derivative of second function derivative of this, if you apply this that d log of x is equal to 1 by x dx, right? So then you will get derivative of this is equal to 1 by this and del ni plus gi. Since del gi is equal to 0, so we have left with this, right? So hope you have understood this. Similarly, we have again applied the same rule in the remaining terms of this equation. Sorry, not this one. Okay, in this equation. Okay, hope you have understood this. Now this derivative is equal to 0 for the maximum condition. That's why this final result of this derivative we have taken is equal to 0, right? Here equation number 4. Hope you have understood this. So here you see this minus sign comes because we have taken the reciprocal of this, right? So hope you have understood this. Suppose you have log of a by b. If you make it negative, then it will be minus log of b by a. That's it. Okay, so that's why it comes here, and this minus, and here you see we have minus this, then we have multiplied minus on both sides. So if you multiply minus with 0 or plus with 0, doesn't matter, it remains 0, right? So now you see we have two conditions. One is the conservation of number of particles, total number of particles n is constant, so del ni, that's going to be equal to 0, and conservation of energy is constant, so that's why we're going to get this two conditions. So now let's apply the Lagrangian method of undetermined multipliers. So how to do that? First, let us multiply alpha with equation number 5, then multiply beta with equation number 6, then add these two equations with equation number 4, and doing so we have got this relation. Okay, so if you multiply alpha with this equation, then you will get alpha summation alpha del ni, that's equal to 0, and with this equation number 6, if you multiply beta, then summation beta ei del ni equal to 0. Then if you add this one and this equation number 4, right, then you will get this result. Here this summation is taken outside the bracket and del ni is taken common. So hope you have understood this. Now let me go to a new slide. Here you see, so here you see this can be equal to 0. It is possible when this part is equal to 0, which is within the bracket. So that's what I have written here, and this implies this. So ln means natural log. When we say natural log, that means here the base is e. Okay, base is e, so that means log of this with base e, right, e is equal to minus alpha plus beta ei. So hope you know what is log. Suppose you have 4 square is equal to 16, that means log of 16 base 4 is equal to 2, right? So in this case, then you see, if log of 16 base 4 is equal to 2, now compare this 16 with this base e with 4 and 2 with this one, then what you will get? If you write this one in this form, then you're gonna have that e to the power this, like here you can see that 4 to the power 2, right, is equal to 16. So similarly, e to the power minus alpha plus beta e I is equal to ni by ni plus zi. That's what we will get. So that's what we have written here. So hope you have understood this. Let me clean these things. Okay. So if you take the reciprocal, then it will be plus, and take the reciprocal. Okay, that's what we have got. Hope you have understood this. Okay, on taking reciprocal, this sign becomes plus, right? Now if you simplify this, if you divide this one by this one, then you will get here 1, and this implies this one. So now let me use this here, you see not this one, and from here let us find ni is equal to this one, right? And this is the Bose-Einstein's distribution law, right? So hope you have understood this. Now let's move on to next question. Next question is 4b, or there is one more question, or. So let me show you. Here is the answer to question number 4b, or this is the first piece, okay, and this is the second piece, okay, this is the third piece, and this is the fourth piece, okay, and this is the last piece. Okay, let me show you one by one again. First, take the screenshot. This is second, third, fourth, fifth, and last, right? Now let me answer to question number 4c. So answer to 4c starts from here. This is the first piece, this is the second piece. So let me show you again. This is the first piece, take the screenshot. Second piece, take the screenshot. This is the third piece, okay, take the screenshot. This is the fourth and last piece, okay. Now let's move on to next question. So question number 5a. So answer to question number 5a starts from here, okay, and let me clear one thing. So when just in this result you replace this E by epsilon, because in the question for energy they are using the symbol epsilon instead of E, okay. When you see E, make it epsilon. When you see EF, make it epsilon F instead of EF, okay, and so on, right? So hope you have understood this. Now let me show you here. So this is the symbol for energy. Here you can see clearly it is epsilon F. So now let me tell you one more thing. This is the first piece, and this is the second piece. Take the screenshot, okay, and this is the third piece, and here is the fourth piece, okay, and this is the fifth piece, last piece. So don't be confused for the term for free electrons in metal, because in the question it is given Fermi gas, for Fermi gas. Now free electrons in metals can be considered as Fermi gas, so don't be confused with that term, okay. So and this EFO and EF, here it is mentioned that let me write this where it was mentioned that let me show you something. Okay, so this EF can be expressed as EFO. So though in the question so instead of EF and EFO you're gonna write epsilon F and epsilon FO as mentioned in the question. And one more thing, in the question this epsilon FO symbol is not there, so that's why you can replace this epsilon FO by epsilon F only, because it is already mentioned here that in this question this EF can be expressed as EFO. That means epsilon F can be expressed as epsilon FO. So that's why both you can replace it by one replace this by this, right? Hope you have understood this. So here is the first piece. This one is the first piece, and this is the second piece. Take the screenshot. And this is the third, fourth, and this is the final expression, right? This is the final expression, and it was asked to write in terms of n by v. So here you can see n by v, and if it is not mentioned n by v can be also replaced by small n, okay. in terms of small n, you can write that one, but in the question it is mentioned that clearly you have to write this in terms of n by v, right? That's why I have written. So hope you have understood this. Now let's move on to next question. Question number 5a or. So answer to this question, link is in the description box. I have written 5a or because I have already made a video on this topic. The link is there, so click the link and go through. Okay, now let me answer to question number 5b. So 5b starts from here. This is page number 1, take the screenshot. Page number 2, page number 3, this is page number 4, right? So let me show you again. This is page number 1, 2, 3, 4. This is the last page. Okay, now let me solve this problem. Okay, so in a system has 7 particles. In a system has 7 particles arranged in 2 compartments. The first compartment has 8 cells and the second compartment has 10 cells. Okay, calculate the number of microstate in the microstate 3.3,4 when the particles are when the particles obey FD statistics, that means Fermi-Dirac statistics. Now let me solve this one here. So this is the question we are to solve. Okay, so now you see, first let me write total number of particles, that is capital N is equal to 7. Okay, the number of cells in first compartment, number of cells in the first compartment, that is Gi. Sorry, let me take G1 is equal to 8, and number of cells in the second compartment, that is G2, so which is 10. It is mentioned here in the question, you can see clearly 10, right? And this 3,4 microstate means, that means number of particles in the first compartment, number of particles in the first compartment, that is N1 is equal to, so 3. Okay, this is N1, this is N2, right? And here you see a number of, so let me write it properly, sorry, number of particles in the second compartment N2, that is equal to 4, right? This is 4. So you see, in case of in FD statistics, we know that thermodynamical probability, this W is equal to given by 4D state N1 N2 dot I comma dot K is equal to this multiplication of, from I is equal to 1, from multiplication of Gi factorial by Ni factorial into Gi minus Ni factorial, whole factorial, right? So let me write it clearly, just give me a second. Okay, that is let me write here W N1 N2 dot I dot K. This represents product from I is equal to 1 to K of these terms Gi factorial by Ni factorial into Gi minus Ni whole factorial. Okay, so here we have only 2 states N1 and N2, so that's why this become W of N1 N2 and in that case this product will be from I is equal to 1 to 2 only, gi factorial by ni factorial into gi minus ni factorial, right? So this represents product. So for I is equal to 1, we're gonna get g1 by n1 into n1 factorial, not only n1, g1 minus n1 whole factorial. Then this represents product, so into, for I is equal to 2, I goes from 1 to 2, right? So g2 n2 factorial, g2 factorial should be there, factorial, I forgot the factorial to write, and g2 minus n2 whole factorial. Now let's put the values here. So now let's put the values. Okay, so you see g1 is 8, g2 is 10, n1 is 3, n2 is 4. Let's put all the values, and putting those values we're gonna get factorial 8, let me write it properly, factorial 8 divided by 3 factorial into then gi minus ni, that is 8 minus 3. So that's gonna be 8 minus 3 is 5 factorial, so here we're gonna get 5 factorial into then g2 is here 10, so we're gonna write 10 factorial, then g2 minus n2, g2 is 10 minus n2 is 4, so and one more thing, n2 factorial is 4 factorial, then into g2 minus n2, that is 10 minus 4 is 6 factorial, right? That's what we will get. So 8 factorial can be written as 8 into 7 into 6 factorial, then 3 factorial into 5 factorial, sorry, let me write one more, 6 into 5 factorial, let me write it 6 into 5 factorial, so that we can cancel 5 factorial, that's it, into 10 factorial can be written as 10 into 9 into 8 into 7 into 6 factorial, so that we can cancel by 6 factorial, 4 factorial into 6 factorial, so 6 factorial cancels. So now this 3 factorial can be written as 3 into 2 into 1, let me write this one as 3 into 2 into 1, right? 3 into 2 into 1 means 3 into 2, right? Similarly this 4 factorial can be written as here you see 4 into 3 into 2 into 1, right? So now here you see this 6 is cancelled by 3 into 2, that is 6, and similarly here 4 to the 8 will be cancelled, then 3 cancels 9 gives 3, right? Then if you multiply all these, then you will get the answer not approximately, just 8 into 7 here 56 into then 10 into 3 30 into 7 210. Okay, that's what we're gonna have. Now let's multiply these two, then this is gonna give you 11760. This is the answer. That's what you will get. That is the number of microstate, required number of microstate. So number of, sorry, let me write it properly, number of microstates in 3,4. So right, hope you have understood this. So that's it, this paper is completed now. Thank you for watching, see you in the next video. Bye bye.